Behind every single blood test, there's a story. But what happens when that story, well, when it just doesn't add up? Today, we're diving into a real medical mystery, and it all starts with one tiny, shrinking red blood cell.
So how do they do it? How do these lab detectives solve a medical mystery before it even blows up into a real problem? That's exactly what we're going to find out. Come on, let's put on our detective hats, follow the clues inside just one vial of blood, and see how these pros crack the case.
Okay, so our story kicks off with something totally routine, a blood sample. But the second it runs through the analyzer, bam, the machine flags an alert. The numbers are weird. They just don't add up. And just like that, an investigation is officially on.
This inconsistency right here, this is our crime scene. It's the very first sign that something's off. But here's what's so wild. The problem might not be with the patient at all. It could be the sample itself. All right, so where does our lab detective even begin? You might think they'd run straight to a microscope, right? Nope. Surprisingly, they start with some simple math, and this is the first clue that's going to crack this whole case wide open. It's this really cool thing called the Rule of Three, and it's basically a super fast quality check. Think of it like a quick gut check for blood work. You've got the hematocrit, that's just the volume of red blood cells, and it should be roughly 3 times the hemoglobin, which is that protein carrying all the oxygen. Simple, right? Okay, let's look at the hard evidence. The patient's hemoglobin is 13.5. So if we use our rule of 3, we'd expect the hematocrit to be sitting right around 40.5%, but look what the instrument spat out, only 33.1%. Whoa, that's not just a little off, that's a major discrepancy. And you can see it right here. This gap between what we expected and what we actually got, that is the massive red flag we've been looking for. For a lab professional, this is like a giant stop sign. It screams, hold on, don't report this result, it's time to dig deeper.
Okay, so the math is way off. Now we've got to switch gears from the numbers to the forensics. We need to figure out what physically happened to these poor red blood cells to give us such a bizarre reading.
Believe it or not, it all boils down to a pretty simple collection error called a short draw. Basically, the tube just wasn't filled with enough blood, and that sets off this crazy chain reaction. First, you've got way too much of this anticoagulant, this stuff called EDTA, compared to the amount of blood. This makes the plasma super concentrated. The technical term is hypertonic. Then, basic biology just takes over. To try and balance things out, water literally gets sucked out of the red blood cells. And what happens? They shrink and get all spiky. And that physical shrinking process, which is called crenation, that is our smoking gun. It is the direct physical cause of that falsely low number that our detective spotted right at the start with the Rule of 3. See how it all connects? So we have our forensic evidence, the shrunken cells. Now, let's connect that physical proof directly back to the weird numbers that started this whole mystery in the first place. Okay, this right here is the key to the whole case. Lab analyzers measure the average size or volume of the cells. That's called the MCV. Since our cells have physically shrunk, that MCV measurement is now falsely low. And here's the kicker. The hematocrit is calculated using that MCV. So if the MCV is wrong, the hematocrit is going to be wrong too. It's this domino effect of errors, all triggered by that one bad measurement. So we've got a solid theory, we've got the numbers to back it up, and we've got the science behind it. But for any seasoned lab pro, the final absolute confirmation comes from stepping away from the machines and using the most powerful tool in the entire lab, the human eye and a microscope. This is it. This is the moment of truth. The lab professional has to make a critical judgment call. Is this just a fluke, a glitch from a bad collection, what they call an artifact? Or are they actually looking at the signs of a real disease, something like anemia? I mean, the patient's entire diagnosis hangs on getting this right. And here it is, the big reveal. Under the microscope, the evidence is undeniable. On the one side, you see the artifact. Look how all the cells are uniformly shrunken and spiky. That's our crenation. But on the other side, you see what a true disease might look like. The cells have these big, pale centers, a classic sign of low hemoglobin. By seeing that uniform spikiness across the board, the detective knows. Case closed. It's a collection error, not a disease. So, the mystery is solved. The lab calls for a new sample, and the patient gets the right results. But let's take a step back. Why is this kind of detective work so incredibly important? It's because
This one single catch protects one patient from being misdiagnosed. Think about that. It prevents all the unnecessary worry, the expensive follow-up tests, maybe even incorrect treatments, all for a condition they don't even have. It's huge.
So let's recap the tools in our detective's toolkit, right? First, you've got the Rule of Three. That's your first line of defense against bad data. Second, you need to understand the science, how a short draw literally shrinks the cells. Third, you connect that physical change back to the numbers to explain the why. And finally, the blood smear under the microscope. That's the final authority, the ultimate judge that separates a simple mistake from a real disease.
It really makes you think, doesn't it? Every single time you interact with the healthcare system, there's this whole hidden world of invisible quality checks and expert investigations, just like this one, all working behind the scenes to protect you. It leaves you wondering, what other invisible checks and balances are out